Dear students, welcome back to my channel Physics World. Today we are going to go to the second part of physical quantities and measurement. So today we shall be discussing the different vessels for measuring volume of liquid. First one is the measuring cylinder. As you can see, this is how your measuring cylinder looks, and the graduations, it is generally made up of plastic or glass, and the graduations increase from the bottom. So the 0th mark is near the base, and the graduations or on the markings of the graduations go on increasing as we move upwards. This is how your measuring beaker looks. This is our second vessel for measuring volume. So generally the milkmen who give us loose milk, they come to our places to give loose milk. They measure the milk with the help of a measuring beaker. Now the measuring beaker has a fixed capacity. It cannot hold liquid beyond a certain capacity. What is the meaning of capacity? A little bit of recapitulation. It is the amount of volume that can be contained in the beaker, right? So this measuring beaker can, if it is filled up to the brim over here, then it will contain only a certain volume of liquid. That's known as the capacity. Over here the capacity of the beaker that is shown is 200 ml. It can be 500 ml also, depending upon the kind of measuring beaker we are using. Next is the Eureka can. Now Eureka can, it contains a liquid only up to the level of the spout. It is just like a beaker with a spout. Now spout is an outlet for the liquid to flow out from this and get contained in some other beaker. So if you pour some liquid over here, it will contain the liquid only up to the level of the spout. Beyond that, if any liquid is poured into this Eureka can, then what will happen? That liquid will flow out, and that can be collected in a measuring cylinder, and with that liquid we can understand the volume, extra volume of liquid which has been poured into this beaker. That can be measured also. So Eureka can comes, we can make multiple use of Eureka can. One of the uses is to find out the density of an irregular solid. Dear students, now the next thing which we are going to learn is the determination of density of an irregular solid. Since density is equal to mass upon volume, we will first determine the mass. And determination of mass first has also got some reason. When the irregular solid is dry, then the mass will be perfectly correct, because if it is wet, the mass of the water will also be coming into the mass. So we want to take a clean, dry, irregular solid and then measure its mass. So step 1 should be to measure the mass with the help of a physical balance or a digital balance. These two are preferred obviously because they are maximum sensitive. Beam balance can be used also because it measures mass. However, the previous two are always preferred for scientific experiments. Next is a step 2 to determine the volume of the irregular solid. Since it is not a regular solid, therefore we won't be able to use the known formulas for the known shapes. So we have to determine the volume of this irregular solid using the displacement method. So over here we take a measuring cylinder and we take initial level of water. Over here the initial level of water that is shown is V1 as 20 ml. It has been shown as 20 ml. It can be anything of your choice. Then you take the irregular solid, tie it with a string and gently pour into the measuring cylinder. Care should be taken so that no water should splash out. So that all the water is there inside only within the liquid. However, we will note that because this irregular solid has been put into the beaker, what will happen is that it will occupy its own volume over there, and so it will displace the volume of liquid or the water which is equal to its own volume. So, the level of the water will be raised. The level of the raised level that has been shown over here is 40 ml. So, over here what I have written is V2 is the final level of water, V1 is the initial level of water. Therefore, V2 minus V1 is equal to V, that is the volume of the solid. Now, we know mass M by the step 1, we know volume V by the step 2. Therefore, density is equal to mass by volume, which can be calculated easily. Now, dear students, we shall be finding out the density, first the volume through the Eureka can and thereby the density using the Eureka can. So, step 1, because we are finding out the density, the step 1 will be to measure the mass. Again, we can make use of physical balance or an electronic balance to measure the mass M. Next, that is step 2, we measure the volume, and this time we are taking the use of Eureka can. So, what we do is we take this Eureka can and take a measuring cylinder also. What we do is put it the water up to the spout, up to here, and then we fill it up to the spout. So, sometimes what happens while filling it up to the spout, some excess water is put, so that drops out from the spout and gets collected in the measuring cylinder. We wait till the water stops flowing out of the spout. Now, it means that the water level is exactly up to the spout. We remove the measuring cylinder, that water whatever has been collected can be used for different purpose. Now, what we do is we take the irregular solid whose volume has to be measured. With the help of a string, we gently dip into the Eureka can. The excess water, now it will now displace liquid or water which is equal to its own volume. Therefore, that volume of water now comes out through the spout and gets collected over here in the measuring cylinder, and that volume can be measured with the help, because of the graduations, we can measure the volume of liquid that has been collected here. Step 3, which is density is equal to mass upon volume. Mass known to us, volume known to us, density can be calculated. Next, dear children, we are going to study the determination of the density of a liquid using a beaker. Now, what will be a step 1? Our step 1 will be to measure the mass of the empty beaker. So, remember that the empty beaker need to be clean, dry and empty. Okay, it has to be perfectly clean, no dirt on that, dry also and empty. Then we measure the mass and let it be M1. And step 2, we pour a known volume of liquid or a fixed volume of liquid into it, whose density is to be determined. So, let us take 50 ml of liquid whose density is to be determined. And so, we know the volume V now. Over here we have taken 50 ml, it can be 100 ml also, it can be 250 ml also. However, that gives us the fixed volume which we have taken. Next is the step 3, to measure the mass of the beaker along with the fixed volume whatever we have poured, and let that be mass M2. So, mass M2 is the mass of the empty beaker, mass of the beaker rather, with the liquid, and mass M1 is the mass of only beaker which is clean, dry and empty. Next is step 4, M2 minus M1. If we do M2 minus M1, M2 is actually the mass of the beaker along with the liquid, M1 is the mass of only the beaker. So, M2 minus M1 gives the mass of only the liquid, that is contained in the beaker. So m2 minus m1 is equal to mass of the liquid. Step 5, using the formula density is equal to mass upon volume, we can calculate the value of the density. Because mass is known now, volume is known now, we simply need to substitute. Dear students, now we shall study about the density bottle. Now we can see over here, this is the design of the density bottle. Density bottle is a specially designed bottle and it holds a fixed capacity of liquid every time. That means the same capacity of liquid it has. So let us see how it happens. This has got a narrow neck. It is a glass bottle with a glass stopper and with a hole in the neck. So if you completely fill up the bottle with any liquid, it will take only that amount of liquid which it can hold. After inserting the glass stopper, the excess of liquid will be flowing out of the hole. So every time it can hold only a certain capacity of the liquid. Now determination of density of the liquid using the density bottle. So first of all, we need to measure the mass of the empty bottle. We shall measure the mass of the empty bottle and let it be mass m1. Now remember that this empty density bottle has to be clean and dry, and we shall be using physical balance and electronic balance as I have already mentioned. Next, measure the mass of the bottle plus the liquid. That means the liquid whose density is to be measured, put it there, fill it up completely and then put the glass stopper, and when the water flows out of the hole, wipe the bottle and then measure its mass. That is gives you mass m2. Next, wash it dry, wash it, clean it, wash it and make it completely dry, and then pour water into it, and in the similar manner completely fill it up with water, put the glass stopper, and when the excess water runs out, wipe it clean and then measure the mass of the bottle along with the water and let that mass be m3. Therefore, now we shall calculate the volume of the bottle. So to calculate the volume of the water, let us first calculate the mass of the water contained in the bottle. So what is the mass of the water contained in the bottle? That is m3 minus m1. Okay. So that is the mass of the water. Why? Because m3 is the mass of the bottle along with the water and m1 is the mass of only the bottle. So therefore m3 minus m1, mass of only the water. Next, we are coming to the so since the mass of the water is this m3 minus m1, m3 minus m1 will also be the volume of the liquid in centimeter cube, simply because the density of water at 4 degrees Celsius is 1 gram per centimeter cube, which means that 1 gram occupies a space of 1 centimeter cube. Then if it is 24 grams, then 24 grams will occupy a space of 24 centimeter cube. So we can safely write that m3 minus m1 is not only the mass of the water, it is also the volume of the bottle. So now we have got the volume of the bottle. Now we can also find out the mass of the liquid. What is the mass of the liquid? Mass of the liquid is nothing but m2 minus m1. m2 is the bottle along with the liquid and m1 is only the mass of the bottle. So m2 minus m1, mass of the liquid. Therefore the density, which is the mass of the substance by volume, is nothing but m2 minus m1 by m3 minus m1 in gram per centimeter cube. Dear students, today I will end this presentation with a small question which will be your home assignment. Now children, you will go through this question and you will be expected to write down the answer Next presentation will begin with the answer to this question. Then at that time you can tell your answer. A given quantity of a liquid is heated. Which of the following quantities will vary and how? Explain your answer. The physical quantities given are mass, volume and density. You have to tell out of these three physical quantities which of them will vary and why it will vary and how it will vary. Okay? That will be all for today. Till then, don't forget to like, comment, share and subscribe. Thank you, children.